Welcome back. In this tutorial, we'll be learning about private variables, static methods, exceptions, and decorators. Basically, a private variable is declared in a class, okay, with preceding underscore of the variable, okay. We precede the variable with double underscores. What this means is this variable will be only accessible within the functions or within the methods, okay, inside the class, okay. You can access it inside the class but not outside of the class, okay. Now we have already learned about global variables. Global variables, okay, first let me on comment here. Okay, so we have already learned about global variables. Soon after the class declaration, okay, whatever variable we are declaring, okay, those without the double underscore in front are your global variables, okay. And if we declare a variable with double underscore in front, okay, is your private variable, okay. Now this underscore p2 is only accessible within the methods of cl1, okay. Here for example, in the initialization method, okay, I have assigned the value of parameter p1, which is by default 11, to p1, okay, which is the global variable, and self dot underscore p2, the private variable. I am assigning self dot p1, okay, plus 10, okay. So if no parameter was passed while instantiating the class, then p1 would be 11, then your this p1 would become 11, and 11 plus 10 would become 21 for underscore p2. Now here I am accessing the displaying the two variables here, okay. Here p1 is global and underscore p2 is your private variable, okay. And here, okay, we not only can define private variables but we can define private methods also, and these methods will only be accessible within the methods of this class, okay, cl1, within the class itself only, okay. So over here within this underscore diffs 1, okay, I'm passing the self parameter, which is very which is the must in most of the cases in Python. Over here inside this cl1, inside this underscore diffs 1, the private method, I am calling the method disp, okay. Now I am declaring another method, okay, diff3, okay, which again calls underscore diff1, okay. So why? Because this disp1 underscore disp1 method can only be called within this any other methods within the cl1. So I am calling it within this disp3, okay. So cl1 underscore dips1, and I'm passing the self, the class itself, as a parameter, okay. Now over here what I'm doing is I'm checking if I'm in the main section, okay. Then what I'm doing is then I'm creating an instance of cl1 with the parameter 20. This 20 will go to p1 now, okay. So p1, now this p1 will become 20, and your underscore p2 will become 20 plus 10, that is 30, okay. Now over here I am calling the disp method, okay, this method, okay, and over here I'm printing the global variables, one by using the class directly and the other using the instance of the class, that is CLI1. Okay, so let's check what happens in this case. Here you get 20, which is the P1 now, and P2, which is the private, as 30. Okay, now referencing global 30, getting global attribute P1 using instance is 20. Okay, now what I'm going to do now is I'll try to reference this or get the value of underscore P2, okay, by using the instance or the class itself outside the class now. Okay, over here. Okay, so what I'm trying to do here is I'm trying to display the value of underscore P2, which is the private variable of CL1, by using the class, and here by using the instance. Okay, so let's see what happens. Here you go, we get an error. Okay, so why error? Because it is a your CL1 has no attribute underscore P2 because it is a private, you can access it outside the class. Okay, so this will not work. So what I just wanted to show is private variables and methods are variables are accessible by the methods inside the class only and not outside the class. Here I'm trying to access the method CLI1 dot underscore dips1, okay, which is your private method. Okay, okay, so let us see whether it works or not. See, it also has no attribute called underscore dips1. Okay, but your underscore dips1 is being used in DSP3, so if I call DSP3 here, it will work. Here you go. Okay, it works now. Okay, so this is how you define and declare private variables and methods, okay, or which are private attributes within a class and accesses within the class. We just need to note that the private attributes are not accessible outside of the class. Okay, okay, now next is static methods. So what is static methods? As of now, you may see here in every class declaration, okay, we are passing the class itself as a parameter. Okay, so here also in diff3 also, but what if we want to write some methods without passing the instance of the class to it? Okay, so that is done by using static methods. Okay, static methods allows to use methods without passing class instance as a parameter. Okay, so over here let's see an example. Okay, sorry. In this example, okay, I'm declaring class, okay, CL2, and I'm declaring an a private variable CNT underscore CNT, and over here I'm defining F1 with passing the instance or the class itself as a parameter, and I'm printing the underscore CNT. Okay, and underscore CNT is being increased by 1 here in the initialization method. Okay, so let's see what happens in this case. Okay, here I'm getting an error because on indent does not match. What is the problem? Line number 7. 1 2 3 4 5 6 7. This is okay. F1 self, define F1 self, line number 7. Okay, I think this is the problem. The diff was the problem. Okay, it should work now. Okay, so it is working now. Okay, so but what if we want to simply do like this and simply want to use cl2 underscore underscore cnt. Okay, if I use self here, okay, and I use this, also would have worked here. Okay, it's working now. Suppose I don't want to use self here because I'm directly referencing the private variable by using cl2 class. Okay, let's see. Okay, it gives an error saying that f1 takes 0 positional arguments but 1 was given. Okay, so it doesn't allow a method without any parameter, which is which is your class itself. Okay, so but if we use static method, okay, this is the way of declaring static methods by using decorator static method. Okay, so before the method, okay, if you write at the rate static method, it means this method will become static and this is okay. Okay, it is correct. Okay, and it allows you to work without any error. Okay, let's see. Here you go, it's working. So if you want to write any method without passing the class instance as a parameter to it inside a class, then you need to declare that class as a static method. Okay, so this is about static methods. Now next one is exceptions. Basically, what are exceptions? Okay, in every programming languages, okay, you may encounter runtime errors. Those errors, okay, you need to handle in order to make your program work more efficiently. That error handling is called your exception handling. Okay, so similar to Java, okay, in Python also you have a way to capture runtime errors, okay, by using exceptions. Here let's take an example first. Okay, here what I'm doing is I'm trying to accept some input, convert that into int and display here. Okay, so let me run it. Okay, let me give 10 first. No problem, it works. But let me give 10.1, 10.1. Okay, it gives an error. Okay, invalid literal for int. Okay, with base 10. Okay, 10.1 cannot be converted into integer. Now when you want to do some exception handling, you need to start the block with the try keyword. Okay, I'm indenting it, and whatever exception you want to capture, you need to capture in the except section. Okay, you can have multiple exceptions handled in the except section. So in the try, you write your code. Okay, and any runtime error that happens within this block, okay, between the try and the first except keyword, okay, block, your those will be handled in your except section. Okay, over here now if I try to run it, okay, and I try to give 10, that's fine. Now if I try to give 10.1, okay, that's not fine, and it has been handled more properly. Okay, instead of going to the Python error, now we have handled it by using our own messages. Okay, here I have more example, more good example. Okay, in this case what I'm doing is in my try section I'm trying to open a file, okay, n.txt, which is in the my base directory from where my Python Anaconda Python is running. and I'm declaring R1 to read the line, okay, and then I'm closing the file here, and after that I'm printing RL, okay, then I'm saying I equals to int of R1 RL, okay. Then in the except section I told you we can accept multiple, okay. Here in the except section, if there is a IO error, I'm saying file error. If there is value error, I'm saying value error. Otherwise, I'm saying unhandled exception occurred. So if you want to display a message when none of the errors are, the error has not been handled in the except section, you can just write excepts and then the information you want to give or what you want to do in that case, okay. So here n1.txt does not exist, okay. So what happens here? File error, because it does not exist, okay. Now let me create n1.txt, okay, new text document n1.txt, sorry, should be just n1, and inside date I'll put 10 and I'll save it, okay. So let's go and execute here now. Sorry, it's, let's make it n1 here, okay. So it's 10, so it is correct, okay, it's working. Now let me make it 10.1, okay. So it cannot be converted to integer, so it should say value error, okay. Let's see over there, value error, okay, it's printing 10.1 and value error has occurred because you are unable to handle this section, okay. This is a runtime error, it's not happening when you are actually programming, because if I just, when you are running the program, because if I just keep 10 here, sorry, if I just put 10 here, it executes successfully, okay. So runtime errors are your exceptions and they are handled by using except keyword, and the statements you want to handle should be within your try block, okay, try and except block, okay. This is similar to Java. In Java also you have try and catch, okay. Over here you have except. In Oracle PLSQL you directly whatever exception occurs directly goes to the exception part if declared, okay. Here now the other thing we want to learn today, we'll be learning today, is decorators. Actually decorators are a beautiful thing that we have in Python, okay. What it does, it takes function as a parameter and returns it with an added functionality, with some more added functionality, okay. Over here, okay, over here I'm declaring a method add beauty, okay, a function called add beauty, and within that I'm passing a parameter x, okay, and here I'm writing another function, okay, dec1, okay, and I'm printing decorated here, and this particular function, okay, I'm calling it here, okay, which is passed as a parameter here, and here I'm saying in this particular function, okay, to return dec1, okay, this dec1. Do remember your function can return another function, okay. Now here I'm declaring another function, okay, defining another function, writing another function ugly, and I'm just printing this is ugly here. Now here what I'm doing is I'm creating I'm calling the function add beauty and passing the function ugly, okay, to, and I'm assigning it to beauty, and now I'm calling beauty here, okay. So let's see what happens. We should get decorated here, okay, and this is ugly. We should get that because we are calling this method is being passed here as x, and x is being called here after this decoration. Okay, after this statement. Let's see here, decorated here, this is ugly. Okay, now writing this way is a quite confusing way, but if we just want to make it more easier and in shorter codes, you can just write add beauty before the method which you want it to be decorated. Okay, so what here add beauty at the rate add beauty means is this ugly function. Okay, whenever it is declared, it will be passed as a parameter to add beauty. Okay, and then this method will be executed and x will be called, your ugly will be called there. Okay, and after this, okay, it's very easy. You don't need to write these codes, this code. Okay, you can just write ugly now. Okay, what this does is it means now your ugly is similar to this part. Okay, so let's see here, it should give the same answer. Say decorated here, this is ugly. Okay, so this is what decorator does. Okay, one very good example here, I've just taken one example here. Okay, in this example I'm trying to write a method, a function div underscore check. Okay, it checks whether a value passed into a function, okay, is 0 or not. If it is 0, okay, then it will just return some message. Okay, else it will return the method. Okay, okay, and after that check 0 is being returned by div check. Now here I'm creating a decorator div underscore check, and I'm defining, or I'm writing the function div underscore xy. Okay, here I'm passing two parameter x and y, and I'm returning x slash x divided by y. Now here what I'm doing is I'm saying print div xy 10 comma 1. Okay, so what happens here is your div xy, okay, is similar to calling this method. Okay, and then if it is 0, it will say divisor is 0, otherwise it will return this particular method, this particular operation, that is x divided by y. Okay, so let's see here, by passing 10 comma 1, or let's pass 10 comma 2. Okay, so it is 5. Now if I pass 0 here, okay, so what it does is now it will execute this part first. Okay, and then only the it goes to the your div underscore xy if it is not 0. Okay, let's see it said divisor is 0. Okay, and this return is none. Okay, so this is how a decorator works. So decorator is nothing, it is just a way of a function taking a function as a parameter and returning it with some added functionality. Okay, it adds some more functionality inside for that particular function and returns it. Okay, so this is all about today what we learned about private variables, static method, exceptions and decorators. Okay, in the next tutorial we'll be learning about meta classes and some more information on classes, and then we'll be moving into NumPy followed by pandas, and then we'll start our first machine learning about linear model in scikit-learn. Okay, scikit-learn. Okay, thank you. See you in the next class.